Now you can see the different block diagram transformation theorem, that is 1, 2 and 3. First is when two blocks are in series, you are supposed to multiply these blocks as an equivalent block diagram. Then if they are in parallel, depending upon the summation points, right, you can say either P1 plus P2 or P1 minus P2. Then next, you can see these are again some of the transformation methods, that is when we are solving the complicated problem for the reduction of block diagrams, these are the, you can say, formulas, or these are the things you are supposed to use in the reduction formulas. If you cross check, the numbers are given on the left hand side. In the next problem I am going to use those particular numbers for solving these complicated problem. I request you to go through these particular all transformations or the equations and how to convert the basic block into the equivalent block. Thank you. Good morning dear student. Today we are going to discuss about reduction of complicated block diagrams by using canonical, you can say, form. The block diagrams of a practical feedback control system often quite complicated. It may include several feedback or feed forward loops and multiple inputs. By means of systematic block diagram reduction, every multiple loop linear feedback system may be reduced to canonical form. The technique developed in the preceding paragraph provides the necessary tools. The following general steps may be used as a basic approach in the reduction of complicated block diagram. Each step refers to specific transformation listed above. Step 1. Combine all cascade blocks using transformation 1. Step 2. Combine all parallel blocks using transformation 2. Step 3. Eliminate all minor feedback loops using transformation 4. Step 4. Shift summing points to the left and take off points to the right of the minor loop. Step 5. Repeat step 1 to 4 until canonical form has been achieved for a particular input. Step 6. Repeat the steps 1 to 5 for each input as required. The transformations 3, 5, 6, 8, 9 and 11 are sometimes useful, and experience with the reduction transformation 7, 10 and 12 technique will determine their applications. And these, whatever I am talking about 1 to 12 techniques, already we had discussed or I have given you in the sheet. Let us discuss. Let us reduce this block diagram to canonical form. If you check in this block diagram, there is a summing point here. I will take 2 summing point and 1, 2, 3, 4 forward loop transfer blocks, and whereas H1 and H2 are the feedback transfer or block. What we will do is we will try to reduce this complicated diagram. First we will concentrate on this part. So you know that if two blocks are in series, the equivalent block for this will be multiplication, that is G1, this is actually G4, G1, G4. This is an equivalent block diagram. I can replace this with the help of this block diagram. Then next, one more we will concentrate on here. There is one summing point and two blocks are parallel. This is G3, this is G2, and this is a summing point. Plus arrows are important. So what will be the equivalent diagram for this block diagram for this? this is plus sign and plus sign. If summing will happen, then you will get equivalent block diagram as G2 plus G3. So this is an equivalent block diagram. So I can replace this block diagram with this. Now what we'll do is, once we replace this block diagram, then we'll go to the closed loop. So this entire loop will become, first G1 G4, equivalence block diagram is G1 G4. Then there is one summing point here, plus, then there is one closed loop or closed loop block or feedback block. Then yeah, this is what you can see. So in this case, what will be the equivalent circuit for this or block for this? As we had already discussed in the previous sessions, right, it is a closed loop, and we can very easily find out the transfer function of the closed loop system as 1 G1 into G4, G1 into G4, 1, as the feedback is sign is plus, I will take minus here, multiplication of all these G1 G4 into H1. So this is an equivalence circuit. So what we did is, now we are going to replace this circuit with this equivalent circuit. We are going to replace this with the help of this equivalent circuit, and we will form one more new circuit. If you cross check, in this case the replacement for this is this. I will just draw the block G1 G4 upon 1 minus G1 G4 H1. I had replaced this. I will summing point as it is. I draw positive, then this feedback block H2. I will replace this block with the help of this G2 plus G3. Then from here it is output C. So suppose this is input R, this is input R, and then again these two are in series. Again these two are in series. What we will do is, we will draw this particular series diagram. I will continue it from here only. Alright. So what we'll do is, we'll take this series equivalence circuit or equivalence block. So equivalence block will be just multiple of these. So G1 into G4, 1 minus G1 G4 H1 multiply by G2 plus G3. So this is an equivalent block for this series blocks. I will draw as it is the summation point. This is a closed loop H2. Right. Now the sign is again here, minus was the sign, right? So minus, this is R, this is H2, and this is output C. If you cross check, right, if you cross check, now this is again a closed loop system. This is, you can say, the forward loop transfer function, and this is the feedback loop transfer function, and this is a summing point. Now we will apply the same, you can say, process. What will be the equivalent, you can say, transfer function? Output C upon input R is equal to, first I will write down this block as it is, G1 G4 1 minus G1 G4 H1 into, I will write down here only, G2 plus G3 all together divided by, again I will write down first one. I will see this symbol, minus is there, I will write down plus, and multiplication of both the blocks. So what is the multiplication of both blocks? I will write it down. H1 into H2. So we'll take LCM. So the LCM will be G1 G4 G2 plus G3 divided by 1 minus G1 G4 H1 divided by, I will take LCM. So 1 minus G1 G4 H1, this will go here, plus G1 G4 G2 plus G3 into H2 as it is, right? Everything divided by 1 minus G1 G4 actually it is H2 because the feedback is H2. This is H2. Now these two will get cancelled. What will be the transfer function? G1 G4 G2 plus G3 divided by 1 minus G1 G4 H1 plus G1 G4 G2 plus G3 H2. So this is a transfer function, or we can say that this is an equivalent block. I will write down as it is. This input is C, output is R, and I will write all this block into this block. So this is a simple reduction of complicated block diagram. I hope you had recollected this. So this complicated diagram we had converted into, right? This complicated diagram we had converted into this block diagram. Thank you.